Namaste students. In today's lecture, we'll be starting chapter 10, straight lines of your class. For doing straight lines, we'll have to recall coordinate geometry that you have learnt in your previous classes. Coordinate geometry, it's a combination of algebra and geometry. So let us recall what all you have learnt in your previous classes. You know, on any given plane surface, we can draw x-axis and y-axis. Whenever x-axis and y-axis are drawn, this plane surface is being divided into 4 quadrants. In first quadrant, both the values of both x and y are positive. In second quadrant, x is negative, y is positive. In third quadrant, both x and y coordinates are negative. In fourth quadrant, x is positive and y is negative. You are familiar with the word Cartesian plane also. X coordinate is called abscissa, y coordinate is called ordinate. We have also learned how to plot the points on a given graph. For example, if we have to plot 2 and 3 on the graph, 2 points from x-axis and 3 on y-axis. So I plotted this 2 and 3. How much is the distance, perpendicular distance of the point 2, 3 from x-axis? How much is the distance? Perpendicular distance of point 2, value of x, from x-axis is how much? 3 unit. And perpendicular distance of this point from y-axis, it is 2 unit. In class 10th, you have learnt different formulas under coordinate geometry. Distance formula, section formula and formula for finding area of a triangle. Distance formula is used to find the distance between two given points. Suppose we are having points P and Q. P is having coordinates x1 and y1. Q is having coordinates x2 and y2. Then distance between PQ can be obtained using the formula x2 minus x1 whole square plus y2 minus y1 whole square. Then under section formula, how to find the coordinates of a point which is dividing two given points P and Q in a fixed ratio m1, m2 internally. Then how to find the coordinates of this point are, for finding x, m1 into x2 plus m2 x1 upon m1 plus m2. And then for finding value of y coordinate, m1 y2 plus m2 y1 upon m1 plus m2. You've also learned how to find the area of a triangle ABC with vertices A, B and C having coordinates x1, y1, x2, y2, x3, y3. For this formula, we have used this x1 multiplied with y2 minus y3 plus x2 multiplied with y3 minus y1 and then x3 multiplied with y1 minus y2 and modulus of the whole will be multiplied by half. So all these formulas we have learned in our class 10th. We have also learned that if area of triangle ABC is 0, it implies that the points A, B and C are collinear points. That means the 3 points are lying on a straight line. Triangle is not formed. Now we'll continue with the study of coordinate geometry to study the properties of simplest geometric figure, that is straight lines. So under straight lines, first topic we'll be doing is slope of a line. Suppose we have drawn x-axis and y-axis. here a line L is drawn. In this case, line will be forming two angles with x-axis. One theta, and if this is theta, the other one will be its supplementary angle, because the two angles formed a straight line are collinear points. So this will be 180 minus theta. So this angle theta is called angle of inclination of this line L with positive x-axis, which is measured anti-clockwise. If theta is the angle of inclination, then tangent theta is called slope. And for slope of a line, we use small m. It is being denoted by small m. So we'll be writing m is equal to tangent theta. That is slope of a line. Always remember, slope of x-axis can come 0 also, and slope of y-axis is undefined. Second case, when we have to find slope of a line L, when coordinates of any 2 points of this line are given to us. For this, I've drawn line L having 2 points P and Q on it. Point P is having coordinates x1, y1, and Q is having x2, y2. And we have to find slope. Slope means tangent theta, and angle of inclination is formed here. For this, we'll have to draw two perpendiculars. One perpendicular, suppose we are drawn QR. QR we are drawing perpendicular to x-axis. And in second perpendicular, we'll be drawing PM on QR itself. If these two angles are of 90 degrees, that means lines are parallel. If lines are parallel means this theta corresponding to this will also be theta. Now for finding slope, you have to find tangent theta. Tangent theta means perpendicular upon base. So for triangle PQM, we can write slope tangent theta is equal to QM minus P. And this is the case when theta is acute. Now what is QM? QM is this distance, and this distance can be obtained if we take QR minus MR. How much is QR? QR is Y2, this distance. And how much is MR? MR is Y1. So we can write QM as QR minus MR. Same way, PM. PM can be written as, this is point of origin, it can be written as OR, suppose this is the N, minus ON. Because whatever the distance NR, same as distance PM. And here it will be OR is x2 and ON is x1. So slope will come out to be y2 minus y1 upon x2 minus x1. In case theta is obtuse, in that case this angle MPQ will be 180 minus theta, supplementary of theta. Then slope will be M equals to tangent perpendicular over base 180 minus theta. Tangent 180 minus theta means minus tan theta. Perpendicular over base, that is QM upon P, means so will be minus QM upon PM. Again QM is Y2 minus Y1. PM. What is the value of PM? PM will be X1, this much is X1 minus X2. PM will be X1 minus X2. Because of this minus, again it will become Y2 minus Y1. This minus will go here, interchanging the position of X2 and X1. So slope will come out to be Y2 minus Y1 upon X2 minus X1. So what is the conclusion? Theta is acute or theta is obtuse. In both the cases, slope of the line will be Y2 minus Y1 upon X2 minus X1. Next case, if two parallel lines are given, condition of parallelism. When do we say two lines are parallel? Suppose we have one line L1 making angle alpha with x-axis and one more line L2 making angle beta with the x-axis. In this case, since lines are parallel, that means they are making, both the lines are making same angle of inclination. That means alpha is equal to beta. If it is so, that means tangent alpha will be equal to tangent beta. And if tangent alpha and tangent beta are equal, that means slope for both the cases is equal. So what we have learnt, in case of two lines, if slopes are equal for both the lines, if their slopes are equal, then the lines are parallel. And if the lines are parallel, slopes are equal. That means two lines will be parallel to each other if and only if their slopes are equal. Then vice versa. Lines are parallel, slopes will be equal. And if slopes are equal, lines will be parallel. Next, what condition will be there if two lines are perpendicular to each other? For example, we have taken line L1 making an angle of inclination with x-axis as alpha. Another line L2 we have drawn perpendicular to the first line, making an angle of inclination as beta. This is 90. Vertically opposite, this will also be 90. And using exterior angle property of a triangle, angle beta is equal to alpha plus 90. So if we try to find slope, means finding tangent, so tangent beta will be equal to tangent alpha plus 90, and tangent alpha plus 90 will lie in second quadrant, means it will get converted into minus cot alpha. Minus cot alpha means minus 1 upon tangent alpha. Now, in this case, suppose slope is M2. So, M2, and in case of first line, suppose slope is M1. So, M2 equals to minus 1 upon M1. That means, if product of both the slopes gives us minus 1, in that case, lines will be perpendicular. And if the lines are perpendicular, then the slopes product will come out to be minus 1.